Hey guys, so this section is called Compound Inequalities, and it's where we end up getting more than one equality going in a single problem. So this first one's just a really basic example of an OR problem. So for an OR, we pretty much just graph what's there. So we have x is less than or equal to 3. So there's our 3, and we'll go less than, so that's that way. And or x is greater than 7. So that goes that way. So what we get is these two distinct graphs with sort of a gap in the middle. And what this OR does is kind of paste those together. The other symbol you'll see for OR is kind of looks like a capital U without the end on it. And it's union is the other word for that. And so all of our OR problems are going to kind of look like this. Here's another OR. This one's slightly more complicated. We just have to do a little bit of algebra to get it solved. So bring the 1 over. This one plus 1. And so here I'll get 3x less than or equal to negative 3. Here I'll get 2x, that cancels, greater than or equal to 4. And then I'll divide. I'm dividing by a positive, so no sign flips. And x is less than or equal to negative 1, and x is greater than or equal to 2. So if we graph our solution set now, we're going to go to negative 1, and we'll have a solid dot going to the left. And then from 2, we'll have a solid dot going to the right. So this next set is AND problems. And ANDs are a little bit different. ANDs are intersections, so ORs are unions, ANDs are intersections. The symbol for this is like that, an intersection. And if you think of what an intersection would be, like with a road, we have these two roads intersecting, and the intersection is the place where they overlap. That's going to be the same thing on a graph. So if I graph this first one, x is less than 5, we're going to use an open dot. I think I'm going to come above the graph here. So that would be this piece by itself, but we're going to figure out if we need both pieces. Here I got x is greater than 1, so we'll come over here to 1 and graph that. So the intersection, the actual solution, is going to be this area where the graphs overlap in here. So none of this stuff out here counts, so you don't want to draw that when you're putting in answers on the homework. You just want to do this part where both graphs are, because that's like where the graphs intersect. So just this line right here would be our solution set. This one, similar. Again, you just have to do a little bit of algebra to get it there. So add my 5 over, 3x is less than 15. Divide the 3 on both sides, and x is less than 5. Here I'll add my 1 over. Oops, nope, I'm going to subtract my 1 over. I get 2x is greater than negative 6. Divide the 2. X is greater than negative 3. And so this is an AND, so it's an intersection. So that means we're looking for where these two things overlap. So if I think of just x is less than 5, that would be up this way. And then x is greater than negative 3, that would be going that way. So then my solution set is going to be between negative 3 and 5. These next two are another way to write an OR. And so we can, instead of saying x is less than 2 or x is greater than 3, we can write it as a continued inequality where we're just saying negative 3 is less than x is less than 2. And so the x is sandwiched kind of between the numbers. It's exactly what the graph looks like. It's just going to go from negative 3 up to 2, and then that would be our solution set. This one's very similar, except we do have to do a little bit of algebra to get there. And sometimes this is a little intimidating, but it's actually not that bad at all. If you think about how you would solve this, you would just add the 3, right? And then next we divide the 2. I do the exact same thing, I just have to do it in 3 places instead of 2 places. So here I get negative 4 less than 2x, and then less than, that's going to be a 10. And then here I would just divide 2, right? So I just do that. I just have to do it one more time over on the left-hand side. So negative 2 is less than or equal to x is less than 5. So if I graph that, I got negative 2 is going to be solid because the equals, 5 is going to be open. And my solution set is all that stuff in there. Okay, and in the lecture section, these last 3 I would have you guys try. So we'll start by just sort of isolating our variables. So move the 1 over, I'll move the 3 over. So that's going to get us to 4x, that cancels, less than or equal to 12. That cancels, and then 2x greater than negative 8. And then we'll do our divide step. X is less than or equal to 3, and here x is greater than negative 4. So graphing those, we'll go negative 4 right here, 3 right here. That's going to be solid. And we want less than 3, but then greater than negative 4. So that's going to be all the stuff in between. And remember, we're looking for where they overlap, so that's going to be that middle area. This one's an OR, so we're going to expect our graph to kind of go that way. Move our 9 over 7. So kind of that same couple of steps that we've done a bunch of times now. And that'll be a negative 3 right there. And then 2x, that's going to be greater than or equal to 4. And then we'll divide over our 3, we'll divide over our 2. And this side gets us x is less than or equal to negative 1. Here we got x is greater than or equal to 2. So we'll go negative 1 right there. And then greater than the 2 is going to go off that way. And there's that graph we expect. And number 9, so this is one of those continued inequalities. So I'm just going to add this, again, think what you would do right there. So I'm just going to add the 6 everywhere. So negative 8 plus 6 will give me negative 2, less than or equal to, that cancels, so I just have the 2x, less than 4 plus 6 is 10, and then I can just divide the 2 everywhere. So negative 1 is less than or equal to x is less than 5. So our graph should look like solid here, open here, and then the stuff in between. So that wraps up compound inequalities.